Now I will start with air outlets. Okay, there are different type of air outlet. You can see there are grills and diffusers. Okay, ceiling diffuser. Then you have a, disc valves. Okay, then there is a louver. There is a sound attenuator. There are different type of fittings are there. Okay, so this how to calculate the pressure drop from the catalog. Okay, say for example, maybe everyone in construction field they know that one, but I will just explain if you have no idea. Okay, so as I told you before, okay, if you go to say for example there is a grill and registers, right? So if you go to any of the catalog, if you go to the selection sheet, okay, here you can able to see the sizes. Okay, so what is the size you have to select? Okay, depends upon the many parameters. You have a velocity, then you have a pressure drop. Okay, then you have a throw, then you have a noise criteria. Okay, then you have a airflow rate, right? This is airflow rate. Okay, so say for example if you want to design the grill, okay, if you go to any of the airflow rate, whatever based on your shop drawing, you can able to calculate the flow rate. Okay, then you can choose the sizing, what sizing you want to choose. Okay, so when you want to choose the sizing, normally as I told you, the velocity as a normal, you can go like a 2.5 meter per second. Okay, and also that is not only the factor, you have to go to the pressure drop. Okay, which is very important. The pressure drop, don't go beyond 10 pascal for the accessories. Okay, so if you go down, okay, you can able to see that unit rate. Okay, you can see the unit rate here, liter per second, the airflow rate in liter per second, then your area in square meter. Okay, and the velocity is in meter per second. Then you have a total pressure drop in water gauge. Okay, to convert into pascal, you have to multiply by 10 so that you can get the pressure drop. Okay, in the pascal. Then you have a throw. Okay, then you have a noise criteria. All the value is mentioned here. Okay, so whenever you do the selections, try to make sure that your noise criteria is within the range. Okay, as per your project, because each and every space having a different noise criteria. Okay, if you go with the higher velocity, then your noise criteria will be very high, then which is not acceptable. Okay, and even if somebody is doing acoustic calculation, when they do the selection, maybe the noise criteria it cannot reach, then the acoustic consultant will tell you to go with the higher uh, the next size of the diffuser or grills. Okay, so if you go to this particular chart, okay, you can able to, based on the airflow rate, okay, go to the sizing and try to match with the pressure drop which is close to 10 pascal. Okay, if you go beyond 10 pascal, what will happen, I will tell you. There is a fan call unit for your apartment, right? So in the fan call unit, you have a normally, what are the type of accessories? You have ducting, then you have a elbow, then you will be having a louvers, or you can, sorry, you have a grills or diffusers, right? And then you have a VCD for air balancing. So this many accessories, or then you have a taper piece. So this many accessories. Okay, if you go to fan call unit as a general, as per the model available with the manufacturer, is the 50 pascal. Okay, sometimes you may also go with the 30 pascal. Okay, as a general, with every manufacturer is available for the 50 pascal. Okay, so when you want to go with the 50 pascal, your say for example your power rating, assume that you have a 1 or 100 watts. Okay, so if you increase the pressure drop, what will happen, your power rating also will be increasing, right? So accordingly your maintenance charges per month or annual operation cost will increase. Okay, to avoid that one, what we are doing, we are doing the fine tuning, like proper sizing of the duct and diffuser, so that your fan efficiency also will improve, and also you have lesser operation cost. Okay, to make it that one, what we are going to do, we are going to limit all the fittings and ducting, everything we are going to limit within 50 pascal. Okay, so how we are going to limit 50 pascal? Say for example, if I design VCD, I have a 2 VCD here. If I go with the VCD, say for example 15 pascal, 15 pascal, then you have a 30 pascal. Then I have a louver. Okay, or grill or diffuser. If I go with the 15 pascal, then all the value will be beyond your value. So whenever you do the proper selection, try to do the proper sizing so that your pressure drop of each fitting will be reduced. Okay, so say for example, if I go with the diffusers, okay, or grills. Okay, so if I go with airflow rate, if I choose the any of the sizing, I will choose close to less than 10 pascal. Okay, say for example, if I choose 500 by 150, say for example 5 pascal, right? 0.461 is water gauge, multiply by 10, I will get 5 pascal. Okay, if you have a 0 degree, okay, if you change the angle to 45 degree, see the pressure drop, it's increasing, right? Because of the angle. Okay, so normally if you go to residential project, normally we select with the 45 degree only, because your airflow should come towards your lower level. Not zero means it will be on the directly on the top. Okay, so normally we go with the 45 degree. So if you go with the 45 degree, what is the pressure drop? 7.44, which is very good. So for this particular airflow rate, for this particular size, you have to select to match with this pressure drop. Okay, so if I have a supply grill and return grill, 7.4 and 7.4, so it will be 15. Then if I go with VCD 5 Pascal, 6 Pascal, then it will be like supply 1 VCD, return 1 VCD, 12 Pascal. So 12 plus 15, 27 Pascal. Then I have a elbow, say 5 Pascal. Then I have a ducting. Okay, so all the value will be within the 50 Pascal, so that you can able to choose that particular model. If you want to choose next model, your size will increase. That will not fit in your space. Okay, you are consuming larger space. Then your weight of the equipment will increase. That will affect your structure. Okay, so there are many factors. So if you go to any of the FCU catalog, normally they choose starting from 50 Pascal. In worst case, you can go with the high static pressure. Okay, when you have a larger pressure drop or large ducting, or you have a different type of accessories, then you can go with the different type of methods. Okay, like different static pressure you can select. Okay, but normally as a fan coil unit, you can stick with the 50 Pascal itself. Okay, so the same method you can apply for all the AHUs, FIHU, or any of the general fans, you can able to apply. Okay, if you have a ceiling method, ceiling diffusers, the same method. If I go to ceiling diffuser, you have a different standard size. Okay, there are different sizes available, but as a standard 600 by 600, 525 by 525, right, and 450 by 450. Then you have a 375 by 375. Then you have a 300 by 300, right? So this is a standard size. So when you do the selection, when you do the airflow rate, okay, based on the velocity or based on the airflow rate, you can able to choose the pressure drop which is 10 or 10 less than 10 Pascal. Okay, or even you can able to select which is better value to comply with the 50 Pascal if you are going with the fan coil unit. Okay, and see the noise criteria 16 Pascal. So if you go to residential apartment or somewhere, the consultant they used to ask for like a 27 NC or 25 NC, something like that. Okay, so when you go to this particular noise criteria is within the limit. Okay, if you go to higher to reduce the sizing, okay, if you have a higher airflow rate, if you want to go with a small diffuser, see the noise criteria and see the pressure drop. This particular diffuser itself is 42 Pascal, so which is very high, which is not acceptable. Okay, but maybe this is applicable for some area, but not for the building services like residential or of commercial building, which is not applicable. Okay, all normally choose with a lower pressure drop. Okay, and if you go to other type, say for example sound attenuator, you can able to size the sound attenuator based on your duct size. Then you can able to give that sound attenuator to your manufacturer. He will do the sizing of the sound attenuator. Then you can able to get the pressure drop from the chart itself. Okay, see the pressure drop based on the airflow rate, based on the model, based on the airflow rate, you can able to get the pressure drop. So this pressure drop you will enter this value. Okay, whatever the grill pressure drop, you can enter the value from the manufacturing data. Okay, and actually this also you can calculate from the ASHRAE itself. This is the manufacturer data. If you have louver, if you have sound attenuator, and any type of air outlet, you can able to calculate from the manufacturer data. Okay, so the value it's available here. Okay, if you go to the louver only little bit different. It's not a direct values. You can take it from the chart. Okay, so first of all, to calculate the pressure drop for the louver. Okay, so if you go to the chart, okay, say for example I'm going with the sand trap louver. Okay, this sand trap louver, I have a pressure drop here, right? So this is a pressure drop chart. Okay, so here you can see that air velocity free area. Okay, so if you go to particular, if you ask the manufacturer what is the free area of that particular model, okay, they will tell you as per the manufacturer standard. They will tell you that 30% or 40% or 50%. Okay, to get that what is the free area, you can able to calculate from here. Okay, say for example this is in inches, right? This is in inches and this is in square feet. Okay, so convert this value in inches or square feet. or this value in square feet. Okay, then you can get the square feet, feet and feet. Then multiply by total area. Okay, so this is the outer, right? And this is the inner. Okay, this is the inner free area. Okay, so when you divide by this value to this value, you will get the percentage. So that is called free area percentage. Any doubt, Martin or Rizwan, how to calculate free area percentage? See, this is the free area, means say for example I have a ducting or I have a any of the accessories. Okay, so this is my ducting, that is my whatever the airflow, it will pass through freely. Okay, there is no obstruction. But if you go to damper, right, damper having a multiple blades. Okay, there is a blade, right, the blade will be angular or 0 degree, whatever it is. Okay, so this blade, that means there is obstruction. If I have a louver, there is obstruction. Okay, so after the obstruction, what is the free area? Okay, so that can be given by the manufacturer. It depends upon what is inside. Okay, there is a different type of blades, different type of rods, everything. So based on that minus, you will get the free area. Okay, so that is the free area. Okay, so this free area is here. You can able to get the chart here. Okay, from the manufacturer. Okay, so based on the free area, how to calculate the free area? For example, say for example, I have a size. Say for example 30 by 30. Okay, so 30 inch means how much, what is the size? 30 multiplied by 25. So I have a 750 mm, 750 by 750 mm louver. Okay, as per my drawing. Okay, and to calculate the pressure drop free area, you can able to calculate from here. Depends upon the free area. Okay, how much free area it is based on the product available. Okay, so based on the available free area, you can calculate. Say for example, this is my free area. Okay, this is my free area. Then based on this particular free area, you can get the, based on the size, you can get the free area here. So based on the free area, you can go to this particular chart, apply here this value. Okay, so this is the air velocity through FPM. Clear, right? So when you apply here this value here, you can able to get the pressure drop. Okay, so this pressure drop, you have to check whether it is able to accommodate or not accommodate. Say for example, sometime if you get 1 inches, that means 254 Pascal, which is not applicable, right? If you go with the 0.1, say for example, it will be like a 25 Pascal, right? 254 multiplied by 0.1 will be 25 Pascal. Okay, which is still high. Okay, but normally you can go with this range. Say for example 10 Pascal, or you can go with say for example 15 Pascal. Okay, when you go with the louver, which is different from the air outlets. Okay, the louver have normally higher pressure drop. Normally it starts from 15 Pascal or 20 Pascal, 25 Pascal. Okay, so from here you can able to get the pressure drop here. Clear, right? So the step very simple. Whatever you have a size, based on the size you can calculate the area. Based on the sizes, you can calculate the free area. So within the free area, you can able to calculate the velocity, because you know the size. You can calculate the velocity. So if you know the velocity, you go to the chart for this particular model. I'm telling. Okay, if you go to this particular chart, you can get the pressure drop here. Okay, so if you go to sealing diffuser, if you go to grill and diffuser, the pressure drop is given directly, but for the louver, it is given in this particular chart only. Okay, if you go to any manufacturer, they will give you in the chart only. Clear, right? Any doubts? Anyone having doubt?